Hello YouTube, this is UMozo3. In the previous lesson, we brought up something called linked lists, and we said basically there are different types of data structures in Java, right? We already know about arrays, and then beyond that, we know about something called array lists, and we said that array lists might be preferred over arrays if we ever want to insert or delete elements, right? Arrays have a fixed length when they're created. They have a constant length. And the nice thing about array lists is that you can add or remove elements, right? It's called a dynamic array. It's much more flexible. And there's typically, more functionality that you have available to an array list than to a traditional static standard array. But in the previous video, we also brought up something called a linked list. So in this video, what we're going to be doing is talking more about the differences and similarities between array lists and linked lists. And I want to show you some of the functionality. I want to show you some more methods that you can use to operate on a linked list. And we really want to be conceptually, understanding conceptually what the difference is between a linked list and an array list. So that's what we're going to be talking about in this video, okay? And we're going to come back to this egg class. Remember in the previous video, in order to practice object-oriented fundamentals, it's nice to be able to work with something other than just like ints, something other than just integers or strings, right? But anything where you could, anything that could be any object, right, could be put into a linked list. And so that's one of the differences that's one of the differences that we drew between arrays and array lists, right, is that arrays can have primitives and array lists cannot. Same thing with linked lists. Linked lists cannot store ints, but it can store integers, right? Linked lists cannot store booleans with a lowercase b, primitive booleans, but they can store booleans with a capital B, right? Boolean objects. So hopefully that's clear to you. But anyway, in the previous video, we made this egg class, right? And we said, so a public class egg, right? And it implements comparable. And the reason why we implement that interface is we've said a couple of times now that every class that implements the comparable interface needs to specify a compare to method, right? And you could verify that for yourself basically by doing a little Google search here. So essentially what you would do is you could look at the comparable interface, right? And you could do a quick little Google search or Blackl search, right? But you could go to comparable, right? And you could say this interface imposes a total ordering on the objects of each class that implements it, right? And so you need to specify what is meant when you try comparing two instances of your class, right? You might remember from previous videos when we were talking about person objects, we said that one person would be bigger than another person if the first person's name were longer, right? But that's up to you how you're going to characterize that. But anyway, this egg is going to be defined by two ints, right? So this would be basically the constructor with parameters, as it would just assign two integer instance variables to the parameters that were passed in, A and B, right? And we said you could either pump A or pump B just by adding one to either of those two instance variables just for fun. And then there's also a resolve method. And so the resolve instance method just returns the difference of A and B for that particular instance. This is a particular instance, and the result of it is going to be instance specific, right? It's not, A minus B is not defined for eggs in general, but it's defined for specific egg instances. Hopefully that's clear to you. And then this is the compare to method. So this is the method that's required every time we implement comparable. And we passed in an object, and the first thing that we did is we converted that object to a more specific egg, right? This is the polymorphism stuff we were talking about, where we said we pass in an arbitrary object, but since this belongs to the egg class, we want to compare two eggs. And so that's why we go ahead and convert Z to Y, okay? So we convert Z to an egg, and we call that egg Y. So hopefully that's clear to you. But we're going to say that my egg is bigger than someone else's egg if the result of my resolve method is bigger than the result of their resolve method, right? So if my A minus B produces -2 and their A minus B produces -6, then basically my egg would be worth more, right? Its compare to method would return a positive number. And the reason why this is so critical is, remember when we were talking about sorting algorithms, right? When we talked about bubble sort and insertion sort and selection sort, I think that was lessons 39, 40, and 41. But one of the things we said is that it's very obvious to be able to sort ints or doubles, right? Okay, we would say 15 is bigger than 12, but how do you sort person objects? How do you sort egg objects, right? So the compare to method enables you to make any object sortable. You could always say that one car is bigger than another car. You could say one rocket is bigger than another rocket. You could say one potato is bigger than another potato. For any type of class or object that you're working with, you get to specify what is meant, what calculation is done if you're comparing two instances of that class. So that's the egg class. And the reason why we made that is because now what we can do is we can have an array list of egg objects or a linked list of egg objects. But what I wanted to do is review ArrayList methods a little bit. So just like ArrayList, there's a wide variety of methods that are available to linked lists. So as we go through these methods, remember that we're not just talking about methods that are available to linked lists, but remember you could also use this video as a little bit of a review of array lists, right? And so all these methods are shared by both linked lists and array lists. And we said that the difference is that linked lists are better for inserting and removing elements, right? It's a much less time-intensive process to insert or remove an element from a linked list than it is to insert or remove an element from an array list. So hopefully that's clear to you. But you can go ahead and look in the documentation, right? And so I already did a couple of Google searches, right? I guess I could be using Blackle if I wanted to care about the environment or how many pennies I wanted to fork over to the electric company every month. But what you would do, so what we can do is we can look at the documentation for the array list and the linked list classes. And I'm just pulling that up on two simultaneous tabs. And you could go ahead and compare the similarities and differences between array lists and linked lists. And so with array lists, it just says resizable array implementation of the list interface, right? And so we're talking about basically elements occupying index positions, right? At index position 4, we have an element, right? An object. At index position 9, we have another element, another object, right? So hopefully that's clear to you. So the array list is pretty similar to an array in some ways, okay? But we would say that a linked list is sort of a little bit further out, right? Like if you have an array here, okay, an array list is over here, a linked list is sort of on the other side. So a linked list is kind of like an array list, but it's not really so much like an array. And the reason for that is because it's still resizable. You can still insert or remove elements from a linked list, but you don't really want to think about a linked list as having elements at particular index positions. That's not really the formulation of a linked list that you want to be familiar with. Instead, one of the things that we saw in the previous video, what we did was we went to Wikipedia and we just took a little look at this, because basically the way that it works is you have these nodes, and what a node is it's composed of two things. It's composed of a value, and it's also composed of a pointer. So it's also basically, there are two fields. There's an integer value in this linked list, like 12 or 99 or 37. But also in each of those nodes, there's a link to the next node, and that's why it's called a linked list. It's because it's defined by nodes that are linked to one another rather than nodes that have particular index positions. Okay, so hopefully that makes sense to you. It's different from an array list, right? It's different from an array list, which has a different sort of implementation or interpretation of it, right? The element at index position 4 here is an 8, okay? But here, we don't really think of index position. We don't really want to think of index positions, okay? We wouldn't really want to say that the element 37 is at index position 2, even though it technically is. We would say that the node that carries, that value, it has that value, and it's also defined by the next node that it points to. It's a linked list. It's a collection of data elements whose order is not given by their physical placement in memory. Don't think really about index positions. You want to think about elements that are pointing from one to the next. That's a linked list. Okay, so hopefully that's clear to you, and there are trade-offs. So one of the things we said in the previous video is that linked lists are better than array lists for inserting or removing elements somewhere in the list, right? We could quickly go somewhere in a linked list and insert or remove an element, but with an array list, that would be a lot more work. And that's one of the things we said in the previous video. So then we can flip the question upside down and we can say, well, why would you ever want to use an array list if a linked list is better at inserting or removing elements? And we're actually going to talk about one feature, one operation that would be better for a linked list, right? So it's a trade-off. A linked list is better for some reasons. An array list is better for other reasons, okay? But what you can do is you can go ahead and compare and contrast the documentation between these two classes. So there's an array list where the elements are sort of based on index positions, and a linked list where the elements are sort of based on how they're connected to the next element, right? That's links. It's like sausage links, right? It's just chain links. And it's just these elements that are chained together rather than elements that are occupying index positions. So hopefully that's clear to you. But the methods are all pretty much the same. So we're looking in ArrayList right now. So right now we're doing a review, right? We already know that we can add elements to the end of an array list. We can add elements to a particular, add a particular index position, then shift all subsequent elements one index position to the right. We can clear an entire array list. We can see if an array list contains an element. We can get an element at a particular index position of an array list, and array lists are actually very, very good at that. So this is a very, very, very good operation to use with an array list. That's actually the trade-off. That's why you would use an array list rather than a linked list, is if you were trying to access an element at a particular index position. So if you wanted to get the element at index position 67, that would be a lot quicker with an array list than it would be with a linked list. But if you wanted to insert an arbitrary element somewhere in the list, that would be better done with a linked list than with an array list. So by virtue of having two slightly different architectures, and by virtue of these two types of lists, which have the same functionality, but they're constructed in a different way, some operations are going to be faster with array lists. Other operations are going to be faster with a linked list. But anyway, what we're doing right now is we're reviewing what we can do with an array list, right? So you can add elements to the end of the list or somewhere in the list. You can see if the list contains an object, right? You can clear all elements from the list. You can retrieve an element at a particular index position. You can figure out the index position of the first occurrence of an element. And remember, we said that the index of method would return -1 if the element appears nowhere in the list. Same thing as if a substring appeared nowhere in a string. Remember, we said the index of method of the string class returns -1 if the substring doesn't exist within the string. And there's also an isEmpty method. We've already talked about these. These would have been in lesson 26 or 27 or 28 or something like that. We have last index of, right? And we also talked about the remove methods. And one of the things we said previously is that the remove method can accept an index position or remove an element at that index position. But it can also accept an object and remove a particular object. And so there's a little bit confusion about if you had an array list or a linked list of integer objects, because what if you had an integer 0 somewhere in your array list or linked list and you wanted to remove 0, right? Well, would that be referring to the element at index position 0? Or would it be referring to the actual 0 element wherever it exists in the list? So I want to sort of demonstrate to you what I mean by that. So what we're going to do, we've already talked about this egg class, right? And so we're going to be using, we're going to be creating a linked list of egg objects, and I wanted to show you how some of these methods work. But what I do is I have a quick example here. So I create 5 integer objects, right? We talked about the integer wrapper class, and we said there's a class called integer which wraps an element of type int, right? And so it's basically a object-oriented representation of an integer, right? And so we have basically 5 integer objects that we create, okay? And we use the constructor that accepts an int, okay? So first we pass in a 4, and then we pass in a 3, and then we pass in a 2, and then we pass in a 1, and then we pass in a 0. And we create an array list called nums, and we're gonna add those 5 integer objects to the array list in the order in which those 5 integer objects were declared and initialized, right? So we add I1, and then I2, and then I3, and then I4, and then I5. And then we say nums.remove of 0. So the question is, do we remove the 4 because that was at index position 0? Or do we remove the 0 even though it was at index position 4? And so now if we go ahead and compile this, what I want to do is I would want to go ahead and print the result. So what I could do is I could say for int k equals 0, k is less than, I guess you could say nums.size, right? And then you could say k plus equals 1. And then you could go ahead and say system.out.println. And then you could say basically nums.get of k dot int value, because we said basically when we were looking at the integer class, we said that if you call int value on a particular integer object, it returns the int that the integer object is wrapping. So we're just going to get the ints. We should get 43210 with the exception of whichever element is removed by this line of code right here, by this call to the remove method. So now if you go ahead and compile it and then you go ahead and run it, we get 3210. Okay, so it didn't remove the 0. It removed the element at index position 0. So it actually removes the 4. Okay, but what you would want to do is if you actually wanted to remove the 0, what you would do is you would write integer.value of and then the 0. So what we didn't really talk about previously but it's helpful to know it now, is that the value of method, it's a static method that applies to the integer class. And so we can go look at the documentation of it real quick, but what we would do is we would do integer Java API, and you can go look at the documentation of this integer class, since we're working with an array list of integer objects. Okay, and basically it returns an integer object. So it returns the integer instance, the actual integer object that represents that int value. Okay, so it would actually look for the 0 in the array list if you said integer.value of 0, right? And rather than removing the element at index position 0. So now if you go ahead and run it, you get something a little different. You get 4321 because it actually removed the 0. Okay, and don't worry about this other stuff. This was happening later on in the main method, but hopefully that makes sense to you. But anyway, I just wanted to show you that, you know, these array lists and linked lists, they have basically all of the same methods. You can remove an element either by index position or by referring to the actual like object element, right? And then there's also, dot set. So you could set an element at a particular index position. We said we could do that with array lists. You can do the size of an array list, okay, and a couple of other ones here. But then if you go over to the linked list tab, so now I switch tabs. Okay, and so linked lists, right? And so you can see a lot of very similar methods, right? And so you can have the clear method, you can have add methods, right? And so you can add an element either to the end of an array list or to a particular index position within the array list. Okay, you can clear the linked list, right? You can clear the entire linked list. You can see if the linked list contains an object. You can retrieve an element at a particular index position in the linked list. But this is an example of a function where the linked list will be a lot slower than the array list. So if you're trying to access or retrieve or modify an element at a particular index position, array lists are a lot better at doing that. What linked lists are better at doing is inserting or removing elements somewhere in the list. Okay, so hopefully that makes sense to you. But all the methods are pretty similar. You still have an index of and a last index of, okay? You still have a remove method, and you can still either remove an element by referring to the index position or by referring to the object itself. There's still a size of a linked list, okay? If you were so tempted, you could convert a linked list to an array, okay? But all these operations are basically the same as with a linked list as they are with an array list. The difference is the time complexity, is how long it takes. So anyway, what we could do is we could go look at a few examples that we had in the previous video, right? What did we do in the previous video? We created some egg objects. So we have E1, E2, E3, E4, and E5, and we're calling on the constructor that we made in the egg class that accepts 2 ints and assigns the 2 instance variables A and B to the 2 integers that are passed in. And then we create an empty linked list of egg objects, right? And we can see whether or not it's empty. And we said that by default, when you create a linked list, it's empty. And so clearly the isEmpty method is going to return true. But you should be familiar with these methods, not only for array lists, but also for linked lists. And so the functionality is the same. And you can still call all of these methods, right? And so one of the things that we did in the previous video was we looked at the isEmpty method, and we looked at the size method, and we looked at the get method, and we looked at the add method, right? The overloaded add method, right? There's 2 types of add methods. One just accepts the object, and the other one accepts an index position and an object, right? And we said that in overloaded methods, you have the same name, but the functionality is different depending on the parameter set, depending on the input set. But you could go ahead and, you could do different things here. And I just want you to be familiar with playing around with the functionality of not just for array lists, but for linked lists, right? And so if you said myEggs.remove of 0, that would remove the first element from the linked list, right? And so what did we do here? Well, we said, well, at index position 0, we want to add E4. So now we should not be seeing really the number 10 unless it came from one of these other computations. Because then when we're going to, actually, I need to put this before we start printing, right? But if I put this right here, right after we add it, we should not see, E4.resolve. We should not see 15 minus 5. We should not see 10 as we defined it, because that element was removed from the linked list. It was removed from the linked list. So now if you go ahead and run the main method, you just get 3, 9, and -1. You don't see the 10. But then if you had commented out, then we would get that computation. So now if you had gone ahead and run it by commenting out the remove, then you could see the 10 that used to be there. So these are the kinds of methods for linked lists. They're very, very similar for array lists. And really you should go ahead and play around on your own and make sure that you can use all 12 formulations here on a linked list, and understand that a linked list is better for inserting and removing elements, worse at retrieving or modifying elements at particular index positions. So I think that's enough for now from UMIL 3. Thanks for watching, and please subscribe.